Hi everyone, welcome back to our channel. Today we are going to solve problem number 27. Find the current through the given load resistor 1.6 ohm for the network shown below using Norton's theorem. Okay, so this is very important. So why this problem is very important is here you have an independent source as well as you have an dependent source. Current dependent. So this is an independent source, whereas this is an 3 times I is there, no? Therefore current dependent polarities are there, therefore voltage source, current dependent voltage source is there as well as an independent source is there. That's why this problem is an complicated problem consisting of independent source and dependent source. So how to solve this problem is, so first we need to find out VOC, and next we need to find out ISC, and the third step we need to find out R Nortons is equal to VOC by ISC, and by the fourth step we have to substitute in the formula in the equivalent Nortons and we need to find out IL. So let's try to see the procedure. Okay, so first let's try to find out VOC. So VOC is obtained, first remove the load. So this load resistor has to be removed. So I'm redrawing the network. So when you remove the load resistor, this is open circuited, then it creates a VOC at this point, which is of 6 ohm. Okay, and this is also an voltage source, which is nothing but 3I. You can see here I want a relationship for VOC. This is one voltage source, this is another voltage source. Okay, so I can write down, apply Kirchhoff's voltage law. Okay, when you apply the Kirchhoff's voltage law, so this is one voltage source, this is another voltage source. Let us try to mark the voltage at this point as Vx. Okay, so the terminals of this unknown voltage is Vx. So whenever the current is leaving, let's try to link all the voltages, which is plus Vx, next one plus 3 into I, next one minus VOC is equal to 0. So we require the value of VOC, that is equal to Vx plus 3I. So to find this VOC, I is unknown as well as Vx is also unknown. So but from the problem itself, I can write down I is equal to Vx minus, you can see here how to write down this current I. Current I is equal to Vx minus 0 by 1. Okay, so I can confirm that Vx is equal to I. So the value of Vx and I both are same. Okay, so this is nothing but I am going to get I plus 3I is equal to VOC. So therefore VOC is equal to 4I. So again we need to find out the value of I. So if you want to find the value of I, we need to find out the value of Vx. Okay, how to find out the value of Vx is, let's try to apply nodal analysis at this point. Apply nodal analysis is nothing but KCL at node Vx. Okay, so that's why these problems are a little bit tough, and definitely you'll get this problem in the competitive exam. Okay, so when you apply the nodal analysis at this point, so what are the entering currents? So 10 amperes is the entering current, and I is the leaving current, and next leaving current is, if you want you can mark this current as some I1 also. So mark this current as some Ix plus Ix. Therefore 10 is equal to I. So how to write down this I is also very important. So I and Ix, how to write down the current in this branch? Okay, so this Ix I can write down it as Vx. Okay, so Vx, and it is leaving here as plus 3i by 6. Okay, already we know the value of I. Okay, so since from this definition Vx is equal to I, so 10 is equal to I plus 3i by 6. Okay, so when you solve it, this one 10 is equal to I plus I by 6 plus 3 by 6i. Okay, therefore 10 is equal to, take I as a common, 1 plus 1 by 6 plus 1 by 3. Therefore you are going to get the value of I, which is nothing but 6. Okay, so we are going to get 6 amperes. Therefore 4 into 6 is equal to VOC. So there's nothing but you are going to get it as 24 volts. Okay, so these problems you have to use a lot of brain. So first I'm linking, I repeat the problem how it is to technically solved. First link all the voltages Vx, this voltage source, and Vy. And here you got two unknowns. First unknown I had solved it assuming from the definition Vx is equal to I. But once again unknown is there. How I'm solving this unknown is by applying nodal analysis at Vx. I 10 ampere source is entering, leaving as I, and the next current is Vx plus 3i. So here also once again two unknowns are there. I want to convert into one unknown, so therefore I solved it to find the value of I. So therefore I got the value of I as 6 amperes. So now successfully we find the value of VOC. And next step we need to find out the value of ISC, short circuit current. Okay, so this is also very important. So what to do here is, so when you're finding ISC, so first redraw the same circuit and remove the load resistance. Okay, so this is of 10 amperes and this is of 1 ohm, and the current of I is flowing, and this is an dependent source, and here you are going to get 6. This is 3i voltage source, and now as soon as remove and short circuited here, therefore this current will flow, which is nothing but ISC. So whenever a short circuit is there parallel to an resistor, these two are connected in parallel. So short circuit parallel to a resistor, when you find out equivalent for this, so this is of 0 resistor, this is of 6, 0 into 6 divided by 0 plus 6, so resultant is also 0. So therefore the same network you will be getting. So here we are going to get ISC with the polarities of 3i, and this is the direction of current, and this is 1 ohm, and this is of 10 amperes. Now how to link or how to find out ISC is very simple. Apply nodal analysis at this point. Okay, so mark this as some unknown voltage Vx. Okay, to link all this, apply nodal analysis. Okay, is indirectly applying KCL at node Vx. So what is entering currents? So 10 amperes is entering. What is the leaving current? I is leaving. And how to write down the next leaving current, which is nothing but ISC. Okay, so we need to find out this ISC, but here unknown is I. Okay, so this 10 I can, how to write down the I? So I have to write down I can write down it as Vx minus 0 by 1 plus Isc. So again this has been transformed into a Vx. So now what to do? Okay, so now Vx. So see here. So this is Vx node and this is the current. So this is one voltage source and this is another voltage source, and this is of positive terminal and this is of negative terminal. So two voltages have to link to establish the connection. So current is flowing like this. So at the same point linking these two, you try to apply KVL. Okay, so current is leaving, or the leaving polarity of the voltage, which is nothing but plus Vx, and current is leaving, or the leaving polarity, plus 3I is equal to 0. Okay, so therefore Vx is equal to minus 3I, and already we have been observed that Vx is equal to I. Okay, so from here I is equal to Vx minus 0 by 1. Okay, so therefore I is equal to Vx. So Vx is equal to minus 3 into Vx. Therefore the value of Vx is equal to 0. So whenever Vx is equal to 0, substitute in this equation. So 10 is equal to 0 plus Isc. So successfully we have been find the value of Isc as 10 amperes. Okay, therefore the Norton's equivalent circuit is as follows. Okay, so the Norton's equivalent circuit, you have an current source Isc is equal to 10 ampere, followed with an branch where this is called Norton's resistance. So Norton's resistance is equal to VOC by ISC. VOC is how much? 24 volts. ISC is how much? 10. So which is nothing but 2.4 ohms. This is 2.4 ohms. Already in the problem, RL is given. Okay, so RL value is equal to 1.6 ohm. Okay, you can see the problem. RL given is how much? 1.6. So now I did the current IL in this branch. So IL is equal to total current. What is the total current? 10 amperes. So in this branch I want the current. What is the branch in parallel to this branch? Which is nothing but into 2.4 divided by the sum of resistors which was connected in parallel, which is 2.4 plus 1.6. So when you solve it, we are going to get the current as 6 amperes. So no confusion, very simple. So those are unable to follow, I repeat the problem. So first remove the load and find out VOC. We are finding the VOC. Uh, this is voltage, this is 1 voltage, this is 1 voltage. 3 voltages I am going to link with the help of KVL. Then I can find out VOC. But here two unknowns are there. So I converted one unknown into another unknown. So I got the value of I. But the unknown I can find out by applying an nodal analysis. Okay, by applying KCL at this point, I am linking the currents I and Ix. So therefore I got the value of I is equal to 6. Substitute here, the problem is solved. Second step is you short circuit the load resistor and apply it. When you apply it, then you are getting one more unknown, which is nothing but Vx. So Vx is nothing but how we can link the Vx, and this one is by applying an KVL. Automatically we can find out this unknown value of Vx. We got it as 0. Just substitute, then you can get. Then draw the equivalent, then find the current. So in the gate, in the competitive point of view, definitely you will get only this kind of problems. Okay, so in external exams, so in the external exams you will get only these questions for the gate. You don't get normal independent source or independent source, combined independent and dependent source. These kind of problems will only appear. Hope you are able to understand. If you feel the content is useful, please like the video, please share with your friends, those who are watching the same subject, and if you have still doubts on this topic, just let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. So kindly support this type of free channels for the development of students as well as for the faculty. Yours obediently, Ram will meet in the next video. Thank you for watching.